Now we have learned about the time complexity notation, etc. Now the time complexity notation, please remember the term asymptotic. Sometimes you will see this term asymptotic time complexity. Asymptotic. What do you mean by asymptotic? Asymptotic means for large values of n. For large values of n. Okay. So you should take any n greater than equal to n naught. You know already, for large values of n. Now today we will start how to solve the means how to find out the solution of the recurrence equation. Means you know the recursion. For example, merge sort, quick sort, you divide the list and then call each sub problem recursively. Okay, so in recursion what happens? This is the main problem. This is the main problem. This is the main problem. Now you divide the list into two problems. So here this is called divide and conquer. Divide and conquer problem. Divide and conquer problem. So here we divide and conquer in this strategy. What happens? A given problem P is there. So we more or less divide it into half of the parts, means n by 2, here n by 2, maybe n by 2 plus 1 or n by 2 minus 1, like that. So anyway, so this is, then you find out the solution of this. You find out the solution of this. How? Again you will further subdivide this. Again you will subdivide. So and you will find out the solution of this part and this part. So these are the sub problems. So these are the sub problems of size n by 2, and this is the problems of size n. But please remember, one important characteristics of the divide and conquer strategy is that your sub problem should be of the same type as of the main problem. Okay, that means the solution technique for sub problem can be applied to main problem also. They are of same type. Only difference is size is less than n by 2. Here n by 2. Okay, then you find out the solution and then merge or conquer and then merge the solution of two sub problems. So this technique is used in so many cases. This technique is used in so many cases. For example, say merge sort, quick sort, and also you see that matrix multiplications or say multiplication of two n-bit numbers. This technique will be used. You already know merge sort. So I am just starting the merge sort here. You see, you know this after dividing into two parts, then sorting, you have to sort the two lists. Okay, so merge list A and list B. So there are two parts. Just a minute. So I am not interested too much about the merge sort because you already know the merge sort. So I am not explaining in details. You know how to merge the two sorted lists. List A is sorted, list B is sorted. But if you merge means you see one thing I forgot to ask one question to you. You tell me what is the difference of say if Tn be the time complexity to find out the sorting in case of merge sort or quick sort for n elements, then what we are doing here, we are finding we are subdividing the problems into two parts. Okay, say this is n by 2, this is also n by 2. So 2tn by 2 plus some constant into n. Have you seen this equation earlier? Because you have already studied the data structure. That's why I'm asking. Tn is equal to 2tn by 2 plus c into n. Hello?
Sir, y plus c into n.
No, I am asking. Have you seen in your data structure class? I did not take the data structure. That's why I'm asking. Tn is equal to 2tn by 2 plus cn.
No, sir, not specifically, sir.
Okay. Okay, then please wait just a minute. So you know how to merge the two lists. There will be two pointers. You know, this is one list, this is another list. Here will be one pointer and here will be one pointer. Say let it be P and let it be Q, and you will access all the elements sequentially, and you will compare the element these two. Which one is the larger than which one? Then you will traverse the list. P and Q will move in this way. You know. So that will take linear amount of time. Now, first you see, in case of merge sort, what happens? Here you see this is the merging procedure. Merge is a procedure or function call that takes two lists, list A and list B. Clear? And they merge the two lists. Now, in merge sort algorithms, what you do? You first divide the list into two parts. Left with the first half of the elements of array A. This is the array A. This is the array A. Then you divide it into two parts. So this is called left and this is called right. Fine. Then you see, I am again subdividing the left part. See that, you please note it down that merge sort. Name of this is merge sort. Clear? So this is also merge sort. Merge sort left means recursively you go on dividing and find out the solution. So this merge sort right. And after that you apply merge procedure. Merge is, which one is the merge? This one is the merge. This is the merge. How to merge. So you know this we call in data structure. Now probably you don't know about the time complexity. Now here if there is only one element or there are no list, no element in the list, that takes constant amount of time. That's why theta of 1. Now if there are n number of elements in an array, then the left half will be n by 2, right half will be n by 2, and then you need to merge the two lists. You see, this merging procedure is this. This merging procedure takes this, because once you divide the left part and right part, then what happens? You are sorting all the elements here. You are sorting all the elements of the left part, and you are sorting all the elements of the right part in recursive way. Now, when you will merge, they may not be sorted. If you just concatenate, then they will not be sorted. You know. So that's why you are using two pointers that I told you, that P, Q. Which one is the largest? In this way, you know this procedure. So you need to access all the elements. You please check it. You need to access all the elements of this list as well as this list to find out the final sorting of all the elements together. So
Sir,
that
why?
means,
Sir, why is it floor and ceiling of n by 2 in the 2t n by 2, sir?
okay. I was expecting this question. I will tell you. But you see that you know that it will take linear amount of time. Just you will compare all the elements and then merge. That's why theta n. So I am not describing it in details because you already studied in the data structure, the merge procedure. Now why it is Tn by 2 and T? See here we are not sure whether n is exactly even number or not. Am I correct? Maybe odd number. N may be odd. So
Yes.
one of the array means here it will contain say one more elements means than others. That's why floor ceiling. But you please remember in time complexity notation, what you are finding order of time complexity. You are not asking exact number of comparisons. Exact number. You are finding order because if the result is suppose say 2n plus 5, then it is also big O of n. And if you are finding suppose 1.5n plus 5, that is also big O of n. So whether it is see instead of if you take just n by 2, so floor means it may be at most what will be the their difference n by 2 floor sorry ceiling and n by 2 what is will be the maximum difference is 1, you know.
Yes, sir.
Here also that will be only at most difference 1. So time complexity calculation will not differ, but we are writing in this way. Why? Because we do not know which side whether they will be equal or not. That's why we are writing in one. If it is say n is even, fine, then these will be both of them will be same, floor and ceiling. Now
Okay.
this is called recurrence relation. You know why it is called recurrence relation? Because the left side is t, right side also contains t. Argument is different. Here larger, it is smaller. Clear? But it contains, so that's why this is called recurrence relation. So recurrence relation is a function or a sequence whose values are defined in terms of earlier values. Same. Just like what do you mean by recursion function? A function which call itself is called recurrence. Recursion. So like this. So actually you don't need you may cut it. This is not required. Okay, this is enough. Okay, this t1 is theta of 1 and this. Now how can we solve this? How can we solve this? So or we can write if n by 2 these and these are same, then we can write also tn will be twice tn by 2 plus theta of n. Okay, now what do you mean by theta of n? Theta of n means any constant c multiplied by n. C multiplied by n. That's why you see, while I was asking that Tn is 2Tn by 2 plus Cn. Are you getting? Just I was asking in
Yes,
merge
sir.
sort.
Yes, sir. Yes, sir.
So this is the reason. T recurrence relation for the merge sort is Tn equal to 2Tn. Just a minute, I am showing here. I have a question here. Tn is 2Tn by 2 plus Cn plus C into n. So in both merge sort and in quick sort, this is true. Quick sort means if I am assuming this is the best case, you know the pivot is chosen. Now pivot may be placed in such a way that the first part has almost n by 2 elements, second half also right part also n by 2, and this is the pivot element almost. Not exact. So in that case, we will get the base case and the time. What will be the solution? Recurrence reason. You are dividing the list into two parts, n by 2, n by 2, and then you are sorting. So it will be Cn. Now, can you tell me in both the cases the recurrence relation for merge sort as well as quick sort, they are same. They are same. But can you tell me what will be the difference? Means actual difference here. Tn is 2Tn by 2 plus Cn. Okay. Now, what will be means actually they differ in this term, although they are same. Means what is the difference with respect to merge sort and quick sort in this equation? Although this is same, can you tell me?
Sir, there is a value of n will be different. Like the value of n in Cn, sir. You get the constant n.
No, 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 no. Okay, see what happens in merge sort and quick sort. What you are doing actually? This is the list. This is the list of numbers, and after that I am partitioning or dividing. So I have a step that is called partitioning. Partition the array. Partitioning. Yeah. And after partitioning, what we are doing? We are solving the left part, right part, and then merging the two solutions together. So merging, this is not merge sort. I am telling merging the two list. This is one step, and partitioning into two list. This is one step. So mainly you see this step and these steps. These are the two steps in merge sort as well as quick sort. Quick sort also we are doing same thing, partitioning the list into two parts and then finally merging. Now quick sort. In case of quick sort, you tell me how much time it takes to partition the list into two parts. Please remember what happens in quick sort. You are taking the first element as the suppose pivot and you are placing at the proper position in the array. Am I correct?
And sir, it will take like order of n times, sir.
Fine, order of n time, because you need to compare the pivot element with all the elements of the array so that you can find out its proper position. That means it will not move when you are completely sorting all the elements of the array. So it will need be go of n time. Fine. And how much time it takes to merge the two lists, left part and right part? This is the left part and this is the right part. How much time does it take? Tell me.
Sir, constant time, sir, because we just shifting the elements, so merging won't take time.
No, make it clear to your friends.
Sir, O1.
We go on. Why? Make it clear to your friends.
Sir, because by shifting the elements, sir, we are already doing like we're doing a virtual merging either way.
No virtual merging. What actually you are doing, you see, all these elements in the left side are less than pivot. This is the pivot. If A is the pivot, then all the elements are less than equal to this, and all the elements in the R are greater than equal to this. Clear? So what happens? That means you need not do anything, because all the left elements are less than A and all the right side elements are greater than A. So automatically you need not compare any element of the left side with the right side to find out the merging. Just means you just concatenate the two lists. So it takes constant time. Clear? Now come to merge sort. What happens in merge sort? What you are doing? How you are partitioning the array into two parts?
Sir, O1, like just making a partition, so O1.
Just making a partition at the middle index.
Yes,
so in array, I can access the middle index const directly. So it takes constant time. And how much time does it take to merge?
Sir, O(n) time.
We go up in time, because I need to compare. Just we have shown you that in the merge procedure that all the elements are to be compared. So big of n time. Now, what is this Cn? This time is, see, this time is for dividing. You are dividing the problems. Okay, means not dividing, sorry, means to find out the solution for the left part, and this is the for the right part. This is left part and the right part. Okay, and this part is actually what? Partitioning plus merging time. So if you see as a whole, in this case, in case of quick sort, these two times big O of n plus big O of 1, that will be C into some constant this. Similarly here also, in case of merge sort, partition plus merge, this is Cn. So although they are same, although these terms is same for both merge sort as well as quick sort, please remember that it consists of actually two steps, partitioning and merging. So partitioning In case of quick sort, partitioning takes big O of n and merging takes big O of 1. Whereas in case of merge sort, partitioning takes big O of 1 and merging takes linear amount of time. Clear? So in this way you should say. Next. Suppose, what do you mean by linear amount of time? Linear amount of time?
The order of one, like the equation is order of one, sir.
Order of n, linear.
Yes, sir. Yes, sir. Right.
Quadratic means?
Order of n square.
Right. Big O of n square. And cubic means big O of
N cube, sir.
n cube. And logarithm, polylogarithm, etc. These terms are there. So big O of
N to the power k.
okay. Okay. Sorry. Now, how can we find out the solution of this? Okay. So, see, this is the recurrence, means that we are telling that why it is floor, what is ceiling. The floor ceiling doesn't matter. So ultimately it will be T2 Tn by 2 plus Cn. So in some books you will get this equation, this, or in some book you will get big O of n like this. And in some books you will get that T1 is just constant, big O of 1. Same thing. So either these or this. Now, how to find out the solution for all this? So there are mainly two methods, iteration method and recursion tree methods. So we will explain all this one by one. First, already I have described in the last class. What do you mean by iteration method? Iteration means you expand, okay, and then find out the solution. So here you see Tn is less than equal to 2 Tn by 2 plus Cn, and T1 is less than equal to C. This is the main equation. Now we need to solve it. So what we will do here, this Tn by 2, you expand it by replacing the Tn is 2 Tn by 2 plus Cn. So therefore Tn by 2 will be 2 into Tn by 4 plus Cn by 2. And if you apply this, so you will get like this, and then finally simplify this line. Then again you apply n by 4, so it will be 4 into 2 Tn by 8 plus Cn by 4. Clear? Because this argument, you check this argument. Here it is n, this is Cn, so it is n by 4, so Cn by 4. In this way you expand. So in this case I will get this. So basically you see this 8 can be written as 2 to the power 3. Similarly Tn upon 2 to the power 3 plus 3 into Cn. Okay, plus 3 into Cn. Similarly here you check, this is 2 square. Similarly this 4 can also be written as 2 square. So here 8 is 2 cube, and this is 8 is also 2 cube, and this is 3. 2 to the power 3, that 3 is here. So therefore if we expand like this, we will get a term here. You check that 2 to the power k Tn upon 2 to the power k plus k into Cn. Is it clear up to this?
Yes, sir.
So next, now what we will do? We know that we need to find out a closed form equation. Closed form means no t should be there at the right hand side. That means I should replace t upon some t within bracket something by some value. But in the recursion, you see no such value has been given except n equal to 1. If the inner argument this is 1, n equal to this is 1, then we can change it by some constant c. So therefore, and also you see this is n. Then in the next iteration it becomes n by 2. So that means n to n by 2 value is reduced. In the next iteration n by 4, again it is smaller. Then n by 8. So that means n is reduced. So that means there is an expectation that it will be 1. So when it can be 1, that means if n by 2 to the power k is 1 or n equal to 2 to the power k, we are assuming that the list contains 2 to the power k elements. Okay. So then log n is k. So next you see that we are the same thing we are doing here. So here you put 2 to the power k, k is log 2n, 2 to the power k is n. So n upon n 1 and k is this. So n into t1, this 2 to the power log 2n, you know mathematics. So this is n. So basically a to the power any log a to the power b, that is equal to b, you know. So use that, and t1 is c, we know already that t1 is c. So put it here. So c into n plus cn log n. So which one is larger? Have larger values? So this, because in the last class I have said already that growth of function, growth of function, growth of function means if this growth of function happens what in this case it is n is like this, n square is like this, n cube is say like this, maybe 2 to the power n maybe like this, in this way. So that which one is the larger in the expression? In this case I am getting n log n. N log n is larger than n, so this, therefore this is big O of n log n. So this is the solution. So this solution is called iterative method. Okay. So this example, this is the example of iteration method. Okay. So you keep plugging the recurrence into itself until you spot a pattern. ক্লাস চলছে, আমি পরে কথা বলছি, ক্লাস চলছে। So in this case we are getting the solution iteration. Now this method is good, but it takes a lot of time. Means you see here you need to expand it so many times to get a general form, then you apply these, then you will get the solution. So to get this means a common pattern, you need to find out a common pattern so that you can arrive such a formula. So if you can arrive at such a formula, then you will apply. So it will take time anyway. So you can apply. This is called iteration method. Okay. Now we'll start reading another method that is called recursion tree method. Means we'll try to create a tree. So how does it look like? Here you see this is the given equation. Tn, same equation. Tn is 2 Tn by 2 plus Cn, and T1 is this. Basically, we know that time complexity means the cost of executing the instructions. Now, how many instructions are executed and what are the cost of each such instruction? Then you will multiply and you will find out the sum. That we have already seen in the first class. So here we will find out the total cost. How? Check. Tn is, this was Tn. Okay, this was the Tn. I am writing here Tn. Now, how? What can I write? I can write Tn is less than equal to 2 Tn by 2 plus Cn. So I am just replacing this Tn by this term. By this term. How? I will write like this. Or better, I should show it in different. Just a minute. Here it will be better. Tn is less than equal to 2 Tn by 2 plus C into n. Now, how we will write? So here, at the first step, I am writing Tn. In the next step, I will replace this Tn by these terms. How? I will create a node. I will create a node, okay, whose cost is Cn, and I will create two child. This is the child, and there, and there are, this is just like this. This will be Tn by 2, and this will be the Tn by 2. Clear? Now again you replace this by extending this tree like this. Say this is Tn, sorry, this was the Cn, and this. So here Tn by 2 also can be replaced by what? Cn by 2. This, its cost will be Cn by 2, and it will be two nodes whose values will be Tn upon 4, Tn upon 4. Similarly, in this case, this is Tn by 2. This also can be replaced by this Cn by 2, and these two have the cost Tn upon 4. Similarly, it also has Tn upon 4. So if you go on expanding, like this, then these will forms a shape of a tree. Okay, shape of a tree. And how does it look like? So it looks like this. Check. Cn, then I have shown you Cn by 2, Cn by 2, and this was Tn by 4, Tn by 4. Clear? Tn by 4. So again you expand like this, and you go on expanding like this. Ultimately, what will happen? The last, this level will have T1. So T1 can be replaced by C, all these C, leaf nodes. Fine. Now compute the cost of at each step. This needs C into n. This is what? This is Cn by 2 plus Cn by 2. That is equal to Cn. Similarly, here you add all the steps in this level. So that means Cn by 4 plus Cn by 4 plus Cn by 4. That will be equal to Cn. So if you go on adding at each level, the total cost at each level will be Cn. Similarly, here also it will be Cn. Now, what will be the total cost? Total cost will be, you have to add all this. So that will be Cn, you add all this sum. Clear? Now, if you go on adding, so what will be the value? You see at the here I am getting T1. T1 is C. So general term was what? Here it was, tell me, Tn by 2, which was expanded. Here it was Tn by 2 square. 4 means T square. So I am assuming that it was Tn by 2 to the power I. Clear? So n by 2 to the power I. So if n by 2 to the power I, so that means should be 1. Otherwise I can't replace it by C. So if n by 2 to the power I is equal to 1, so that I can replace it by T1. So I will be, so what will be the value of I? Then I will be 2 to the power I will be n. 2 to the power I should be equal to n, or I should be log to n.
Sir, we can also say we should add Cn log n times because height of the binary tree is log n.
Yes, no, I am just showing mathematically. Yes, that is also correct. So anyway, you will get this. So, and you know n log n is the larger value. So therefore, its time complexity will also be the n log n. So this method is called recursion tree. This method is also called recursion tree, and it is helpful, okay, to find out the solution for this. So and now another.
So one question, sir.
Yeah.
Sir, if you are adding Cn log n times, why is the extra Cn, sir? Is it for the first, the topmost one, sir? The extra
This
Cn?
is see. This is the n by 2 to the power 1. You see, Actually, this is n by 2 to the power 0. You check it, argument.
Yes.
So
Got it.
0 to I plus 1. So that. Now, how can we prove it more formally using induction? Induction plays an important role. Okay. So how can you show that if n is a power, then prove then Tn is Cn log n plus Cn. You have to prove this, because if you can prove this, then you can tell that time complexity is this. So by induction means what happens as the base case means we are assuming this is correct. Now I have to show assumption, induction, base, assumption, and steps. So for n equal to 2 to the power 0, 1, then what happens? Tn is T1 and T1 is less than equal to C, we know. Now is it, can I write this, that C that is equal to what? C into 1 means n value is 1, n is 1 in this case. So C into 1, and that is equal to Cn log n plus Cn. Why? Because if you put n equal to 1 here, then what happens? Log 2 1 is 0. So this term is reduced to 0, and this is C into 1 C. So that means anyway induction base we have proved that it is correct. T1 is less than equal to C. Now for induction as assumption, we assume that this claim is correct. This claim holds good for all values of n prime less than n. Okay, all values of n prime less than equal to n. Please see this means n may be 1, n may be 2, whatever it may be, but it is true only for less than n. So I have to prove that this is also correct for n equal to n. So if Tn, I am not using this formula. Check what I will use. I will use that recurrence relation. I know it was given that Tn is less than equal to twice Tn by 2 plus Cn. Okay, Tn is less than equal to twice Tn by 2 plus Cn. So if I now you see I am getting 2 Tn by 2 plus Cn. Now this n by 2, this is less than n. Clear? Now by induction assumption we can apply this, because we have assumed this, that this claim is correct for n less than equal to n. So this n by 2 is also less than n. So I am applying this. So you write Cn by 2, Tn is Cn log n plus Cn. So I am writing Cn by 2 log n by 2 plus Cn by 2. Fine. Now C2, just these two will cancel out. This will be the next step. Then log a by b means log a minus log b. You apply that, and here log 2 is 1. Please remember. So log 2n minus log 2. So that is 1 plus Cn. Right? So Cn, and we are getting this Cn log n plus Cn. Clear? So we have proved that Tn is also it's really correct, is less than equal to Cn log n plus Cn. So in this way we are getting that the time complexity of the merge sort or quick sorts are always like this, means n log n. Now so one thing, see T, so therefore if anybody asks you if Tn is twice of Tn by 2 plus some constant into n, okay, otherwise it is constant, means I am not saying if n is greater than 1. Okay. So what will be the solution here if it is d, if n is 1? So we will say the solution is big O of n log. Just you please remember this. This is very important, because you will face this type of solution so many times, recurrence equation, and you will get this solution. And one trick is that if it is like this, say Tn. Okay, before telling the tricks, you tell me what will be the time complexity, means what will be the solution for this, say only this C.
Sir, O of 1.
What will be the time complexity?
Sir, O of 1, sir.
Project was saying, na? You
Yes, sir. Yes, sir.
any other? You can apply the tree method that I have said, not tree, means you expand it. Have you seen this type? Can you tell me this type of equation occurs when?
Sir, log n, sir.
Right. Now tell me why. Means have you seen this type? Is it resembles to which problem?
Sir, simple example, we can take 1, 2, 4, 8, means powers
No, no,
of.
no, no, no. I know that you are getting the solution miscalculated. I am not asking that. I am telling it resembles to which binary search,
Binary search, sir.
because you see this is the list of integers, and what you are doing, I am first computing the middle element. I am comparing this a mid, array mid, this value with the key value. If the key is greater than this, then I know key will occur here, and at that time I will throw out this portion. I will throw it out. I will not accept. So that means half of the elements will be used. So if half of the elements are used, so in next part I am just throwing half part. So Tn by 2, okay, and plus C means you know that you are comparing these two elements. That's why it takes constant time. And if n is equal to 1, there is only one element, then it takes only constant time. Is it clear? Why this problem is similar to this? Means actually this is the equation of the binary search.
Yes, sir. Now got it, sir.
Now calculation part, you see, don't, I am not asking you to map the problem to the binary search and then tell okay it is log n. No, not like that. What you will do, you see, I can write like this: Tn is, sorry, Tn by 2 plus C, and this can be expanded as Tn by 4 plus C plus C. That means Tn upon 2 square plus 2C. In the next case, you will check Tn upon 2 cube plus 3C. So in this way, what I will get? Tn upon 2 to the power I plus I into C. And that is will, so here, now I know that this will terminate if this n equal to 1. If n equal to 1, then Tn will be D. So n by 2 to the power I, you put it 1, so that it becomes what? T1 plus I into C. What is the I? N is 2 to the power I, or I is log 2n. 2n, and this is multiplied by C. This is multiplied by C. Now T1 is D. D plus C log 2n. So this is clear. So you please try to remember this, means Tn by 2, half of the elements are there, and this, so you that will be C. Just a minute. That binary search that I was saying. You know the algorithm, and this is the iteration method. Recursion tree, same. C only, then again C, again C. How many times? That you can compute. Now, can you tell me what will be the uh, time complexity if this is the case? Say, what will happen here? Then in the next step, I can write it
2 into 2 into 2 n by 4 plus 2c.
so it becomes what?
So 2 to the power I
Square n by 2 square
plus 2c.
c plus 2c, na?
Yes, sir.
And the next case 2 cube t to the power n by 2 to the power I plus, you tell me, c
I
plus 2c plus 2 square, na?
yes, sir.
4c means 2 square c.
Yes, sir.
So 2 to the power I t n upon, oh sorry, this is the 3, n upon 2 to the power I plus c 1 plus 2 plus 2 square plus 2 to the power I. Now tell me what will be the value? Okay, you do these things. Okay, home as a homework. Now
Sir, big O of 2 power n.
we go 2 to the power n. You check it. Now next, I am just telling one part that suppose this is the problem. This is the problem, and you are actually, what does the meaning of this equation? In other words, I should ask like this. A Tn by 2 plus Fn. Tn is A Tn by 2 plus A Tn by B plus Fn. So this is the main problem, P. Okay. Now what we are doing, we are dividing these into some sub problems. These are the sub problems. Like this. Sub problems are equally in the same type of the main problem, but the sizes are smaller. So the size of, so I am dividing it into so many sub problems. Okay, so that means the size of the sub problems are n by b. Size of the sub problems are of n by b, and you are taking a such sub problems. You are not considering all the sub problems, you are considering a of A subproblems. Fine. And you are merging the solution of those subproblems. So Fn means merging the solution of subproblems. Not only this, but also it's partitioning the problem into subproblems. Partitioning the problems and merging the solution of subproblems. That takes a function of n. It may be linear, it may be quadratic, it may be log n, it may be constant time. And ATN by 2, what is the A? A means number of subproblems that you needs. And Tn n by b, this n by b is the size of the subproblem. For example, in case of binary search, what is the value of A? What is the value of A? Binary search?
Sir, binary search 2, sir.
A 2 or 1?
Sorry, sir.
A
1.
1. Right. And B is 2. You need two subproblems, but you need actually one subproblem, but you are dividing it into two parts. Okay. And the size of the subproblems are n by 2. Clear? So this is the actual meaning, but you will see in the next class, means I will show you that this is in these terms we will solve what will be the solution for the recurrence using master method. So we will see that Tn is equal to Atn by b plus Fn, like that. Okay. And okay, so today we stop. So tomorrow we have a class Monday, na? Yes. So we'll take. Thank you.
Thank you, sir.
Thank
Thank
you,
you, sir.
everybody.
Thank you, sir. Sir, when will you share the slides for this part, sir?
These parts,
Yes,
I have just started today.